Assalamu alaikum wa rahmatullah. What's going on, guys? Welcome to AmigosCode. Today I'm super excited. As you can see, I'm super excited because I'm doing a collaboration with Nana from Tech World with Nana. Nana, go ahead and say hi to the community. So Nana, she's got a YouTube channel called Tech World with Nana where she provides awesome content on DevOps. And because I've got a course on Docker, and she's really good explaining Kubernetes content, we've decided to collab and put a full course just for you. So this is everything that you need in order to get started with Docker and Kubernetes. So if you are not part of the AmigosCode community, go ahead and join now. There are over 8,000 people. Also subscribe to Nana's channel. The link will be in the description of this video. And if you haven't smash the like button, please smash it right now because it helps us to keep on providing content like this.
Thank you, Nelson, for your introduction. I'm also very excited to teach this course together with you. If you guys have any questions during the course or after the course, or you want to simply stay in touch, I would love to connect with you on social media, so be sure to follow me there as well.
Without further ado, let's go ahead and learn about Docker and Kubernetes. Right, before we kick off this course, what I want to tell you is that you should be practicing as we explain. So as Nana and I explain, you should be practicing because there is no point of view just watching the videos and do nothing, right? So Docker and Kubernetes are really awesome technologies, and the way that you're going to learn them is by practicing. Please practice. Also, if you have questions, feel free to contact us. And the easiest way is actually to be part of the community because the community is so engaging and you can ask questions. Everyone will be there to help you, and also you can share your expertise. This is all I wanted to say before we kick off this course. Next, Nana and I will give you an overview of this course. To kick off this course, we're going to start with Docker, and we're going to take a website as well as an API that we will build and then use Docker to package up things into images and then run containers. So you'll see how Docker works. So Docker just simply makes it easy for you to take whatever you build locally and then run it onto a server that has the Docker runtime environment, right? So if it works on your machine, it will also work on this server or anywhere that has the Docker runtime environment. And we're going to cover pretty much all the concepts that you need in order to use Docker with full confidence. Then after we understand exactly images and containers, right? Then we need a way of taking those containers and run it somewhere where those containers can be orchestrated for us. And this is when Kubernetes comes into play. So let me actually pass it to Nana so that she explains exactly what she's going to be teaching you and what is Kubernetes.
When you learn containers and Docker specifically, you can now start building complex applications with tens or even hundreds of containers that talk to each other or interact in some way. And of course, these containers would need to be deployed across multiple servers in a distributed way. So you can imagine the overhead and effort you would have if you had to manage these hundreds of containers manually with little automation. Every time the containers crash or the communication between them across the servers isn't working, you would have to manually interfere and fix these problems. So it would be great to have a tool that would automatically detect these problems and fix these issues itself to recover the application state. And that is the container orchestration tool. And Kubernetes is currently the most popular container orchestration tool out there.
Thanks, Nana. That was an awesome explanation about Kubernetes. Without further ado, let's go ahead and start our journey learning Docker and Kubernetes. All right, let's go ahead and understand what exactly is Docker. So Docker is a tool for running application in an isolated environment. So it's very similar to a virtual machine, but it's much faster and doesn't require a lot of memory and an entire operating system to operate. The cool thing about Docker is that your app runs in the exact same environment. If it works on my machine, it will definitely work on your machine. If it works on the staging environment, it will also work in the production environment. So this is one of the benefits of Docker. And pretty much it just works, right? If it works on my machine, then you are guaranteed that whatever you deploy your application, it will also work. And Docker nowadays is the standard for software deployment. Pretty much everyone is adopting Docker in their workflow for software deployment because it makes it easier for packaging applications. You don't have to deal with different OS, different distributions, and pretty much whatever you package will work in production. So pretty much almost every company is adopting Docker, and you should be aware of how to use this tool as well. So what exactly is the difference between containers and virtual machines? So a container is an abstraction at the app layer that packages your code and dependencies together. Multiple containers can run on the same machine and share the OS kernel with other containers, and each running as an isolated process in user space. So this is very important because a container doesn't require a full operating system, and it simply shares the underlying operating system but running in isolation of other containers. In contrast with virtual machines, is an abstraction of physical hardware turning one server into many servers. The hypervisor allows multiple VMs to run on a single machine. Each includes a full copy of an operating system. This is very important, a full copy of an operating system. Also, the application, necessary binaries and libraries taking up tens of gigabytes. And also they are very slow to boot. So just let me show you exactly a visual diagram. So this is a containerized application. So you can see that you have multiple apps. Underneath you have Docker and nothing else. So Docker manages all of the containers that you spin up. And underneath Docker you have the host operating system, and then you have the actual infrastructure. In contrast with a virtual machine, you can see that you have the infrastructure. On top of that, you have the hypervisor, and this allows one server to be turned into multiple servers. And you can see that each virtual machine requires a full guest operating system. So this is the fundamental difference between Docker and virtual machines. So the benefits of using Docker is that you can run a container in seconds instead of minutes. As you see that for you to spin up a full operating system, it takes a while. Also, less resources results in less disk space as well as less memory. So these are very good advantages of using Docker instead of virtual machine. And as I mentioned, you don't need a full operating system. So these are some of the advantages of using Docker, but obviously you have things such as deployment and testing. So you can test things locally and then you can take it to whatever environment, and it is absolutely guaranteed to work. If you have any questions, go ahead and drop me a message. Otherwise, let's move on and learn how to install Docker. All right, let's go ahead and learn exactly how to download and install Docker. Navigate to docs.docker.com/install. So right here, you can see that you can download Docker for Linux, Mac OS, and Windows. So the process is the exact same thing whether you are on Windows or Mac. So because I'm on a Mac, let me go ahead and show you exactly how to get it for Mac. But for Windows, it's the exact same thing. I'm going to show you in a second. So go ahead and click on Mac OS. And then you can see that to download Docker for Mac, head to docker.hub. So what I'm going to do is press Command and click on the link. And then right here, you can see that I can get started with Docker. So what I need to do first, so to download Docker Desktop, so this is what we need, is to pretty much create an account or sign in. And once you have the account, you will be able to install Docker. The process is very straightforward. So you can see the requirements. So Mac OS Sierra 10.12 or above. So if you are using a previous version, you need to download Docker Toolbox. So Docker Toolbox is the old way of using Docker, and Docker Desktop is the newest and better way of working with Docker. So let me go ahead and pretty much show you exactly how it works, or actually how it's downloaded. So you can see that they have a screenshot. So basically, once you have an account, then you'll be able to download Docker. So basically you take this docker.app, put it into your applications, and then you'll see that you have Docker. And then at the very top on your toolbar, you can see that you'll get a Docker logo. So this logo right here, and you can see that it will say Docker is up and running. And you can see right here in my machine, because I already have Docker installed, you can see that Docker is up and running. So it's very straightforward to get started with Docker. So for Windows, it's pretty much the same thing. So what I'm going to do is collapse this, click on Windows, install Docker on Windows, and you can see that it's the exact same thing. So download from Docker Hub. There we go. It's the exact same thing. So please log into download. And then once you have it downloaded, you can follow these instructions right here. But basically, it's the exact same thing here. So if I scroll down, you can see that you have Docker for Windows. You will also get the actual Docker logo. And then you'll see that Docker is now up and running, which is the exact same thing that I have here. So go ahead and download Docker Desktop for whatever operating system that you are using. And if you have any questions or if you get stuck, go ahead and drop me a message, but this should be very straightforward. In the meantime, join me in the next one. Now that we have Docker installed, go ahead and click on this Docker logo icon at the very top. And you can see that we have a couple of options right here. So we have preferences, updates, documentation, more of Docker, sign in, and Kubernetes. So what I want you to do first is to open up your terminal or command line and simply type Docker. And you should see that you get a bunch of commands. So you can see that you get a bunch of stuff really. So options and then management commands. And you can see all of these commands that we will learn in this course. So you saw that you can type Docker, but also if I go ahead and type Docker -- and then version, you can see that this is the version of Docker that I have installed on my machine. This might be a bit different for you, but the commands will be the exact same thing. So what I want you to bear in mind is that if I click on the Docker logo again, and then quit Docker Desktop, and then type Docker, and for now, simply go ahead and type Docker PS. You can see that cannot connect to Docker daemon right here. So the Docker daemon is not running. So whenever you are using Docker, make sure that the actual Docker daemon is running. So let me go ahead and simply run it again, and let me skip this version, and you can see that it's starting. Just give it a second. You can see that it's starting right here. And there we go. You can see that it's green. If I now go back to terminal and type docker ps, you can see that this time it works, right? So just to bear in mind that whenever you want to use Docker, you have to make sure that the Docker daemon is running. And there we go. You now have successfully installed Docker and know how to get it up and running. Let's begin our journey in learning Docker. Let's begin our journey learning this awesome technology called Docker. All right, let's go ahead and learn about Docker images and containers. So an image is a template for creating an environment of your choice. This could be a database, a web application, an app that does some processing. Pretty much it could be anything. An image is also a snapshot, and you'll learn more about this. But basically, you can create multiple snapshots, i.e. versions of your image, and then you can point to whatever version that you want at a particular time. So let's say that you deploy to production an image, you find out an error, and what you can do is simply go back to the previous image. What is so special about an image is that it contains everything your app needs to run. It contains the operating system, any software required, as well as the application code. So once you have an image, then containers come into play. So a container is simply a running instance of an image. So what you do first is you have an image, and then from that image, you simply run a container. Let's go ahead and download an existing image and run a container from it. All right, let's go ahead and pull an image and run a container from it. So navigate to hub.docker.com, and right here you can see a list of all public images. So right here, so you can see that if I scroll down, you have a list of official images. So these are companies, for example, such as Nginx, Mongo, Node, Redis, Ubuntu, Couchbase, Golang. So there are tons of these official images that we can use, but also there are some unofficial images. So these would be, for example, someone like yourself or I that don't necessarily own a large company, but we just build images for other developers to use. So we could also distribute these images inside of this Docker registry. So Docker Hub is simply a registry, and we're going to learn more about registries later on, but a registry is simply a place where you can download images. So you can see that I can explore some images. So let me go ahead and simply explore, and you can see that there are tons of these images, right? So I can scroll down, and the list is endless. So the one that I want to try out with you is this one, Nginx. So what I'm going to do is, if you don't see this image right here, so Nginx, so scroll up, and right here simply type Nginx. So I always get this wrong. So Nginx, just like that. So I always get this name wrong. So Nginx is simply a web server, a reverse proxy, a load balancer, and it's very popular and it's used all over the internet. So if I scroll down, you can see that they have some tags, and we're going to learn about tags later on. Dockerfile as well. Later on, we will learn about this. And they have some quick reference. So what is Nginx and how to use this image. So let's actually scroll up, and you can see that they have this command right here. So docker pull and then Nginx. And let's go ahead and pull this image. So let me go ahead and open up terminal, or you can use command line if you are on Windows. So let's simply go ahead and say docker and then pull and then ng and then x, just like that, and then press enter, and you can see that it's using a default tag, and it's actually downloading Nginx for us. So just give it a second, and I'm going to explain all of this later on. But basically, if this image changes, it doesn't have to download every single layer again, so it is cached. There we go, and you can see that it has downloaded a newer image for Nginx and then column latest. So this part right here is the actual tag, and we're going to learn about tags later on. But basically, this is simply getting the latest image. Now, in order for us to see a list of images that we have locally, simply go ahead and type docker and then images. And there we go. So you can see that the image that we have currently is this one. So we only have one image, and the name is Nginx. The tag is latest. This is the image ID, and you can see that it was created about 3 days ago, and the size is 109 megabytes. There we go. You successfully managed to pull your very first Docker image. Next, let's go ahead and run a container from this image. Let's go ahead and run a container from this image that we've just downloaded. So Nginx, and then the tag is latest. So remember, a container is a running instance of an image. So to run a container from an image, simply type docker and then run, and then we have to specify the actual image. So in our case will be Nginx, and then you have to specify the tag. So in our case, latest. So if I press enter, you can see that we get nothing. So believe me or not, but we are actually running a container. So the reason why this is hanging, because the process has started and is just waiting. So what I'm going to do is open up a new tab, and inside of this tab, what I'm going to do is first, let me actually make this bigger. And so something like that, so you can see exactly what we're doing. So what I'm going to do now is describe the list of all running containers. To do that, simply type docker and then container and then ls. Press enter. You can see that we have this container with an ID of 83910ABD360C, and then the image is Nginx latest. You can see some commands created about a minute ago. The status is up about a minute, and you can see that the ports, it's 80. So 80, I'm going to explain the port in a second. And the name is Happy Volhard. So I'm going to explain this bit in a second. So this port right here, because it's very important for us. But you can see that we have an image up and running. So go back to the other tab, and you can see that right here. So this is actually a bit bigger now, but basically the process is hanging right here. So what I'm going to do is simply cancel out of this. So Control C. There we go. I'm going to clear the screen there. And right here, simply type docker container and then ls. And you can see that the container is no longer up and running. So the same here. So remember, this was a container. So docker container ls. You can see that nothing is up and running. So what I'm going to do now is close this tab. And I'm going to run the container. So docker run Nginx latest. But now what I'm going to do is add a flag. So minus and then D. So this simply says run this container in detached mode. So if I press enter, you can see that the process is no longer hanging. So it's running in detached mode. And then we get this ID right here. So now we can view the list of all containers running. So docker and then container and then ls. Enter. You can see that this is our container, which is up and running 18 seconds ago. So let me go ahead and clear the screen. Another way that you can check the list of running containers is simply type docker and then ps. So this is the preferred way and much faster. Enter, and you can see that we get the same thing. And now you can see everything is the same apart from the actual name right here. So suspicious Snyder, and the port is the same. So this port right here I'm going to explain next, but this is very important for us to understand. So 80 and then TCP. And there we go. So you successfully managed to run your very first container by running docker run -d in detached mode, and then the name of the actual container. So nginx and then latest. Next, let's go ahead and learn exactly how we're going to be able to use the container. So far we have our host, which has docker running. So we are running docker in our computer. And right now we have one single container, which is running nginx. And this container is exposing a TCP port, and the port is 80. So let me show you exactly this again. So right here, you can see that we have ports and then 80 and then /TCP. So what we want to be able to do is, from the host, we want to issue a request to our container, which is exposing port 80. So we want to be able to go to our web browser, type localhost 8080, and then that port 8080 should be mapped to port 80 on the container. So basically we want to go from the host to the container. And the way that we achieve this is simply by adding -p before we run the container. So -p 8080 from the host should be mapped on port 80 on the container. And then we'll be able to access the application running from within the container. So let's go ahead and open up terminal or command line. And what I'm going to do first is stop this container. So to stop a container, simply type docker and then stop and then pass the container ID. So I'm going to command C that, command V, and then enter. And you can see that the container has stopped. So if I type docker ps, you can see that nothing is running. Let me clear the screen. So I'm going to issue the same command. So docker run -d or -d. And then let's go ahead and say dash and then p. And we want to go from the host. So whenever we type localhost 8080, we want that to be mapped to port 80 on the container. So press enter. And you can see that the container is up and running, docker ps, and there we go. So now you can see that the ports is a bit different. So you can see that right here, we are simply saying map localhost 8080 to port 80 inside of the container. Now let's go ahead and open up any web browser. And then simply type localhost and then colon 8080 and then enter. And there you go. So you can see that we have this welcome page that says welcome to nginx. And there we go. So we've managed to map the host port 8080 to the container port 80. So let me go ahead and pretty much just stop this container. So docker and then stop and then pretty much just get the ID. There we go. If I now refresh, you can see that the site can't be reached. So we've mapped port 8080, but you could also map a different port. So let's go ahead and map port 3000. There we go. Now, if I change this to port 3000, and you can see that it's working, but from a different port. We could also map both port 8080 and port 3000 to port 80 inside of the container. So let's go ahead and do that. So let me go ahead and simply stop the container. So I think this will be now a different container. So let me go ahead and simply say Docker and then PS, grab the ID, Docker stop. There we go. Clear the screen, Control L. Now, if you want to map more than one port, simply add another -p 8080 to port 80. Enter. Now, if I type Docker PS, you can see that right here, localhost 3000 maps to port 80 inside of the container, and localhost 8080 also maps to port 80 inside of the container. So let's go ahead and test this out. So if I refresh, this should work. So 3000 works, and now 8080, and this also works. There we go. You now know how to map ports from the host to containers. If you have any questions, go ahead and drop me a message. Otherwise, let's move on. Let's go ahead and learn exactly how to stop, remove, start, and name containers. So if I go ahead and type Docker PS, you can see that currently we have this container right here. So this is the ID, and it's mapping both port 3000 and 8080 to 80 inside of the container. So this is what we have currently, right? So this is the Nginx, localhost 8080, this works, and localhost 3000, this works. So the way that you stop containers is simply by saying Docker and then stop, and then you can pass the ID or the actual name. So let's go ahead and grab this name right here. So Command C, paste that in, and then enter, and you can see that we get the name back. Now, if I check my web browser, refresh, you can see that it's not working because we stopped the container. Now, an interesting thing is we've just stopped the container, but we haven't removed it. So the container is still available for us to start. So to start the container, simply grab the same name and say Docker start, and then the same name or the actual container ID. Enter. You can see that I get the name back. If I check my web browser, and there we go. So you can see that the page is working again. Now, let me go ahead and stop this container. So it's Docker stop. And this time I pass the actual ID. And let me clear the screen for now. Refresh the web browser. You can see that it's not working. If I go back, so how do you know the list of containers that are not running? So if I type Docker PS, you can see that we have no containers right here. But indeed, what this command does, so Docker PS, it simply lists the running containers. So go ahead and type Docker and then PS -- help. And right here, you can see that you can pass some options. So -A for all, and you can see that the default shows just running, and you can do some filtering. You can do quiet, that displays only the numeric IDs, and you can check the size as well. So let me go ahead and simply clear the screen and type Docker PS - and then A. And you can see that we have a couple of containers right here, and all of them are Nginx. So remember, up to now, we've actually stopped many containers and then we start them again. And whenever we start them, we simply got a different name. So you can see that this is a different name. This is a different name. The same here. And also the ID, right? We get a brand new container. So we've never reused existing containers. Now, how do we delete containers, right? So how do we delete containers? So to delete a container, so what you need to do is simply say docker and then rm, and now you can delete a container by the actual name or container ID. So let's grab this very first one right here, created 25 minutes ago, and you can see the name is Elastic Sanderson. Paste that in, enter, we get the actual container back. Now if I type docker and then ps -a, you can see that the container is gone. So if I remove that, and remember, I've actually searched before, so this is the actual ID that we removed, and you can see that it's no longer in this list. So just let me cancel out of that. You could also remove every single container in one single command. So you could say docker rm, and then you could say I want to delete that one, and then you'd say I want to delete this one as well, so docker rm. But you can see that it's a bit tedious. So what we can do is grab every single ID and then pass that into a command, and then we will delete everything. So the way we do it is simply, so if I clear the screen, so docker ps --help, you can see that we have this quiet, so display only numeric IDs. So let's go ahead and say docker ps - and then a, meaning that I want every single container, including the ones which are stopped, and then q for quiet, that gives me only the numeric IDs. If I press enter, you can see that I've got only 5. So if I want to remove all of these, I simply type docker and then rm, and then press $, and within $, simply say docker ps -a and then q, right? So we're simply getting this command and passing it inside here, and this will remove every single container that we have. Now bear in mind that if you have a container that is running, this won't work. So let me first delete, and then you'll see it. So if I remove everything, you can see that I get every single ID back. Now if I type docker ps -a, you can see that we have no containers available. Now let me go ahead and start a container. So if I click the screen, so let me search here, so 3000, and let me go ahead and start this container. There we go, docker ps, you can see that it's running. If I refresh the browser, there we go. Now if I go ahead and simply try and remove the container, right? So let's go ahead and run this exact same command, so docker rm, and then give me all the containers. So if I press enter, it says that you cannot remove a running container. Stop the container before attempting removal, or you can do a force rm. So the way that force rm works, so you simply pass -f, and it simply says that I really don't care whether it's running, I simply want to remove the container, and that's it. So if I press enter, you can see that that took a while, and I get the ID back. So if I refresh the page, you can see that we have no containers. Now if I do a docker ps, and there we go, docker ps -a, enter, and we have no containers available. If you have any questions on stopping, starting, and removing containers, go ahead and drop me a message. Next, let's go ahead and learn how to name containers. All right, let's go ahead and start a container. So simply type docker run -d -p, and then expose whatever ports that you want, and then press enter. So if I type docker ps, you can see that we have a name right here, so elegant and then ride. So usually this is a random name that is given to you if you don't specify a name, but in reality, when you create your own containers, you should be giving them a name so that you don't rely on the ID nor the actual random name, right? So the way that you give a name to a container is simply by using dash dash and then name. So let's go ahead and simply stop this container. So docker, actually, let's go ahead and force remove everything. So docker rm -f docker ps and then -aq, enter. There we go. So now let's go ahead and run the exact same command. So docker run -d. So what I'm going to do is go to the start, and then right here simply go ahead and type dash dash and then name, and now we can give this a name. So let's go ahead and simply say that this will be our website, right? So now if I press enter, you can see that the container is running. But if we type docker ps, you can see that now the name is website. And this makes your life much easier for you to identify your containers. And trust me, you should always name your containers, because most likely you'll be running multiple containers at the same time. So now I can simply go ahead and say docker stop and then website. And you can see that I don't have to rely on the actual container ID. I could use it, but because I've named my container, I can simply say stop my website, just like that. So if I press enter, you can see that stopped the website, and I can simply start it again. So docker start and then website. So there we go. You now know how to name containers. Let's go ahead and learn exactly how we're going to take docker ps and format this result right here. So you can see that sometimes it might be a bit difficult for you to read what's going on. So you can see that we have container ID, and then the ID, it's right here. And then we have the status, and the status goes over to the next line. And then we have the image, and you can see that the ports, then it's, yeah, sometimes it's very difficult for you to read. Let's actually go ahead and start a second container. So docker and then run and then -d -p and then nginx and then latest. And let me actually name this. So dash name and then website and then 2 and the port as well. So let's go ahead and simply map 9000 to port 80. So press enter. You can see that it's running. So if I do a docker ps now, you can see that I've got 2 containers up and running, and the output is it's even harder to read actually. So what we can do is simply use a format. So we can say docker ps and then minus format, and this is equal to, and what I'm going to do is simply copy some code right here, but basically this simply gives a label and then tab, and then right here it grabs the actual ID. The same with name and then names, image and then image, ports, so on and so forth. And you can get this entire line in the description of this video. So let me go ahead and simply Command C, go back, and what I'm going to do is simply paste that in, and this has to be within quotes. And if I now press enter, you can see that now the format is much nicer. So you can see that we have the ID, the name, image, port, command created, status, and basically it's much easier for you to read if you don't have enough room. So what I like to do with this is simply export to a variable. So format equals to, and then paste that again. Oh, actually, I need to paste this again. So copy and then paste that, enter. And now if I type docker ps, you can see that it's not formatted. And if I type docker ps dash dash and then format equals to $sign and then format. So this is the name of the variable. So this $sign format refers to this variable right here. So if I press enter, and let me do that again so you can see exactly nice and neat, and there we go. So you can see that it's formatted, and there we go. You now know how to format the results of docker ps. Alright, in this section, let's go ahead and learn about Docker volumes. So Docker volumes allows us to share data. This could be files or folders. So you can see on the diagram that I have here that you have a container, and then you have the file system, and under that you have the Docker area. And through the container and the file system, you create a volume. So I'm going to show you exactly this in a second, how it works. But volume simply allows us to share data between host and container, and also between containers. So the way it works is that you have a container running on a host, and in our case we have an Nginx container. So we have to create the volume, and then this volume allows you to share data between the host and container, and vice versa. So let's say that we add a file in our host, in our machine. This file A will also appear in the actual container inside of the volume. The same by adding a file in the actual volume inside of the container, that will also appear in my host operating system. And the same is true with folders. So if you add a folder on your host, then that will also appear in the actual container. Let's go ahead and learn exactly how to share data between host and container. Alright, so go ahead and navigate to help.docker.com and search for Nginx. And right here, what I want to show you is exactly how we're going to be able to serve our own files during development with Nginx. So scroll down, and right here you can see that hosting some simple static content. And basically you can see that right here. So they give a name to this container, so some Nginx, and then -v, and then this is the actual volume. So this bit right here is the source, and this is the destination. So inside of the container, so this path right here, so user share Nginx and then HTML, inside of that folder we can share our own files. And if you are developing an application or a website, that's where you should put your files in. And then right here you can see that this is a read-only volume. So let's go ahead and pretty much create a file and then mount our directory inside of this folder so that we can override the default Nginx welcome page. So let me go ahead and open up terminal and docker run and then --name. Let's go ahead and create a website. So I've deleted all the previous containers, and -p and then 8080 to 80, and then the actual container will be ng and then next, and I can say .latest, or if I don't specify the actual tag, it will bring latest by default. So if I run this, or actually let me actually add -d for detached, and then if I go to my web browser, refresh, you can see that's forbidden, and this is because this is 8080. And there we go, we have this default Nginx welcome page. In the next video, let's go ahead and override this default web page by simply mounting a volume from the host to the container. All right, let's go ahead and create a volume between our host and our container. So inside of our desktop, so in the host machine, we will create a folder called website, and then we're going to have an index.html. So that file, or the contents inside of the website folder, will be shared inside of the container in the following directory. So users, share, nginx, and then HTML. So that way, when we hit the URL in our web browser, we will be served with our own files. So let's go ahead and do that now. So right here, what I'm going to do is pretty much just open up VS Code and go ahead and open up your favorite IDE. But in my case, I'm going to open up VS Code. And then what I'm going to do is simply create a new file. And then in this file, let's simply go ahead and have an h1. So this will be some HTML. So h1, and then hello, Docker, and volumes. So we will have a better page, but for now, this will be enough. So now go ahead and save this. Navigate to desktop. Inside, create a new folder. Name this as website. And then create. And then name this as index.html. Press enter. And there we go. Now what I'm going to do is start a container and mount the website folder to our container. So go ahead and open up terminal. And right here, let me simply say Docker and then stop and then website. There we go, Docker rm and then web and then site. There we go. So this is completely removed. So now let's go ahead and navigate to the website folder. So cd and then desktop. And there we go. And also cd into website. So if I do an ls, you can see that we have index.html. Now let's go ahead and start a container and then mount the entire folder to our container. So the way we do it is, let's go ahead and scroll up, or actually go up a couple of times. And now what we're going to do is, so pretty much after website, so after you name the container, go ahead and simply say dash and then v. And then right here, we can simply say $, and then within brackets, pwd. So this simply takes the present working directory. So let me actually show you. So let me cancel out of that. If I type pwd, I get the content. So this is what I get, right? So if I pass that, so I think on Windows, you simply say dir and you get the same thing. So let's go ahead and grab this again. And then what we're going to do is we're going to mount this folder called website to, and remember, so if I open up nginx, you can see that this is the actual destination. So user, share, nginx, HTML, and then you can say read only. So grab everything and then go back and then paste that in. And there we go. So now let's go ahead and press enter. And there we go. You can see that we have started a container. And if I now go to my web browser, and then remember before we had this welcome page, which was the default presented by nginx. Now if I refresh, you can see that we are serving our index.html. So let's go ahead and change that. So let me go ahead and simply say hello with volumes, and then let's simply say read and then only. Save this, go back, refresh, and you can see that the contents are mounted, right? So whenever we change the index.html, that is reflected in our container. So what I'm going to do now is I want to show you that if we have a file inside of the container, that will also appear in our host. So go ahead and simply type this docker and then exec and then -it and then simply say website and then bash. So this simply says that we want to execute this in interactive mode, pass the actual container, and then we want to execute the bash command. So if I press enter, you can see that now we are inside of the container. So if I type ls-al, you can see that this is the Linux file structure inside of our container. So remember, this is the running container. So now remember, we mounted user share nginx HTML. So let's go ahead and navigate to that. So cd and then user share nginx HTML. And then if I clear the screen, if I do an LA or actually ls-al, you can see that we have our index.html. Now let's go ahead and simply say touch and then about.html. And this is just a file with nothing inside. So if I press enter, you can see that this is a read-only volume, which means that the container can only read the contents. If it wants to add, if it wants to write to it, it's impossible. So the way that you tackle that, so let's go ahead and exit this container. So Control and then D, and then docker ps. Let's go ahead and simply say docker rm-f and then website. There we go. Now what I'm going to do is simply run the exact same container, but right here, instead of passing the read-only flag, I'm going to remove that. Enter. Now let's go ahead and bash into the container again. So docker exec -it website and then bash. Enter. cd to user and then share nginx HTML. If I clear the screen, now if I do an ls, you can see that we have index.html. If I touch about.html, press enter, you can see that works. Now if I go to my desktop, and you can see that we have this folder right here called website. So I'm going to open it up, and you can see that we have the about.html right here. So from our container, this file also appears in our host, and you can see that this still works. And there we go. This is how you share files between the host and containers using volumes. All right, let's go ahead and customize our website. So this website right here, which simply says hello Docker and volumes. And by the way, that's not read only anymore. So let me go ahead and remove that. And if I visit the page again, refresh, you can see that hello Docker and volumes. So go ahead and navigate to Google and do a search on Bootstrap single page template. So go ahead and click on this very first link. So free Bootstrap 4 landing page themes. And right here, go ahead and pick any website of your choice. So what I'm going to do is pretty much just pick this one right here. So grayscale, and then click on view on GitHub. There we go. So now let's go ahead and simply clone or download. Let's go ahead and download the zip. Now open this in your desktop, and then let me unzip this. There we go. Delete the zip. And what I'm going to do is pretty much just take everything. So I'm going to take everything here, Command C, and then go to my website, and then let's delete everything and then paste. There we go. So you can see that we have this index.html, and we can go ahead and delete this folder. So Bootstrap grayscale master, delete that, and there we go. So now I'm inside of the container. So I'm going to do an ls -al. you can see that we have the files that we've just downloaded. So what I'm going to do now is simply visit the web page. So I'm going to close this and this as well, and go ahead to localhost 8080. Before we had hello docker and volumes. Now if I refresh, you can see that we have this awesome website. And feel free to make changes to this website according to your needs. So you can see that this works beautifully, right? So you can see that we have a nice, beautiful website. So I can click on projects. You can see that takes me to projects, contact, and there we go, right? So let me go in about, and you can see that it's built with Bootstrap, and you can see that it's working beautifully. And there we go. I just wanted to show you that you don't have to have a boring website as we had. So you can go ahead and build your own website and then deploy it with Nginx. All right, now let's go ahead and learn how to share volumes between containers. So we have a container A and we have a container B, and we can share a volume between them, i.e. we can share the contents of a folder or a file between these two containers. So let's go ahead and try that out. So currently we have this Nginx container named website, and it's serving our beautiful website. So you can see that running on localhost 8080. The way that we can share files or folders between containers is by using a command volumes from. So go ahead and type docker run --help. And this will give you all the options that you can use with docker run. Enter, and you can see that at the very bottom you have volumes from. So -- volumes from, and then mount volumes from the specified container. So let's go ahead and clear this, and then docker ps. So let's go ahead and start a brand new container. So docker run, and then --name. Let's go ahead and call website -copy, and then and then d minus and then p. So this will be 8081 to 80. So port 80 is already being used, so we have to map to a different port, and then go ahead and simply say ng and then next. And right here, what we need to do is simply say volumes, right? Because we want to map a volume from this running container. So the way you do it is --volumes and then from, and then you pass the actual name. So the name of the container is website. Now let's go ahead and press enter, and you can see that it's up and running. Docker, or actually let me press up 2 times, clear the screen. You can see that we have 2 containers running. One container is available through 8081, so that's the port, and this is the website copy, and the website is through our 8080 port. So let's go ahead and give that a go. So open up your web browser. So 8080, so this is the main website. So refresh, you can see that this still works. Now if I go ahead and hit the 8081, which is the website copy container, and we shared all the contents from the website container to the website copy container, this container should have the exact same website. So if I press enter, you can see that still works. So we've managed to share data across these 2 containers. All right, in this section, let's go ahead and learn exactly how to use Dockerfile to build our own images. So far, we've been using existing images, i.e. the Nginx image, and from that, we've been running containers. So what a Dockerfile allows us to do, it allows us to create our own images by creating a file called Dockerfile. And this file simply contains a list of steps of how to create images. And then we can run images built from Docker files as we've been running existing images. Let me go ahead and show you the documentation that you need when building Docker images. Alright, so right here, this is the Docker file reference. So in this page, you can find every single command that you can use when building images. So as I mentioned before, Docker file, it's simply a series of steps that defines how your image is built. So in this page right here, you can see that they have quite a lot of things, but if I scroll down, you can see that they have stuff with environment replacement, Docker ignore, and then the from keyword. So every single Docker file has to have this from keyword. So I'm going to explain this in a second. And then you have the run command, and then you have the cmd command. You've got label, you've got expose, you've got add, you've got copy, entry point, you've got args. You've got a bunch of these commands that allows you to build Docker images. Let's go ahead and create our very first Docker file and then create an image from it. Alright, let's go ahead and take this beautiful website and build an image using a Docker file. And then we can pretty much run as many containers that we want from our custom image. So far, we've been mounting a volume. So if I show you exactly what we've been doing. So right here in this command, so we've been mounting a volume from the host to the container. So this is why you can see this beautiful website. So we are taking all the index.html, all the JavaScript, pretty much. So if I do an ls here, or actually ll, so you can see that we have a bunch of things. So we have CSS, images, JS, vendor. So basically we have everything, and then we mount a volume inside a container, and then we are able to view this awesome website like this. So this is really good for development purposes. So you want to mount the volume when you are doing stuff in development, but when you want to build a custom image, you don't need to mount a volume from your host to the actual container. So what you ought to do is to copy. So you want to copy everything into your image, right? So when you're actually defining how you want to create an image, you ought to copy this so that you don't have to mount a volume. So let's go ahead and learn exactly how to do that and then run a container from it. So what I'm going to do here, so I want to pretty much just say Docker, and then let me clear that. So I just press Ctrl L, image, and then ls, and you can see that we have the nginx image. So this is the latest tag, and that's the one that we've been using so far. And I've gone ahead and deleted all the previous containers, and I'm only left with one container, which is running our website. So Docker ps, or actually let me format this, so like that. So you can see that, so that and that. So you can see that we have one image, and we also have one container, which is running based off this image. So what we want to do now is create our custom image and then run a container from it. So right here, we don't need to mount a volume anymore if we are building our own image that contains everything. And remember, images should contain everything that your application needs to run. So it should contain all the dependencies, all the source code, pretty much everything that your application needs to run. And that's what we're going to do now. So go ahead and open up VS Code or any IDE and open up the website folder. So inside of this website folder, let's go ahead and create a Docker and then file. So this must be named as Docker file, and make sure that this is inside of the root folder. So inside of the website folder. So right here, the very first command that we're going to learn is the from keyword. So from keyword is the name of the base image that we want to use. So usually when you build your own images, you will never build an image from scratch. You will always use an existing image as your base image and then produce your own image. So in our case, we want to use the nginx and then column and then latest. So you've seen this already. So when we say docker run, we're running this image right here. So we want to build an image based off this image right here. So this image called nginx. Now the second command that we're going to do is we're going to say add. So let's go ahead and say add and then simply say dot. And then we want to add everything in the current directory. So CSS, image, JavaScript, pretty much everything right here into a destination. And if you remember correctly, so the destination that we want to add is this one right here, right? So this is where the static content should live if you want to serve static content with nginx. So let me go ahead and simply paste that in. So this is from, and then this is the actual destination. And let me go ahead and save this. And this is pretty much a very simple Docker file that will produce an image. Now that we have a Docker file, next, let's go ahead and learn how we're going to build an image from this Docker file. So go ahead and open up terminal or command line if you're on Windows, and make sure to navigate to the website. So right here, if I do an ls, or actually la, you can see that I have my Docker file right here. So the way that we build images from Docker file, it's simply by running this command. So we need to say docker and then build. So we want to build, and we have to specify few parameters. So at least we must specify the tagging. So how we want to tag this image. So go ahead and simply say dash dash tag, or simply dash and then t. So let me go ahead and say dash dash and then tag. And in fact, let me show you the commands. So docker build and then dash dash help. So here you can see the list of all the commands that you can use when building from a Docker file. So right here, so this is the one. So dash t or dash dash tag. So name and optionally a tag in the name and then the actual tag. So this is the format, right? So let's go ahead and simply clear this. So let's go ahead and say docker and then build and then dash and then dash tag, so that you remember that dash t is dash dash tag. And then let's go ahead and give it a name. So the most obvious name is website. And then right here, let's simply go ahead and give this a tag. So the tag will be latest. And I'm going to show you exactly the best way of you tagging your images later on. But for now, let's simply go ahead and say that the name, right? So when you tag, you say that the first part is the name. So the name is website. And then the version is latest. So the same way that you saw with nginx. So if I cancel out of this for now, so docker and then image and then ls. So right here, you can see that the name is nginx and then the tag is latest. And the way that we refer to it is simply saying n and then ginx and then column latest. So we are doing the same thing for our own image. So let's go ahead. So let me go ahead and simply grab this, and then right here, so this is the one. So dash t or dash dash tag. So this is the format, right? So go ahead and simply copy this, and then paste it in. So let me go ahead and simply grab this, and then clear the screen, Control L, paste that in. And then the last thing that you have to specify is where is your Docker file. So my Docker file is inside of this directory called website. So simply go ahead and add a dot. So this will look for a Docker file and then build an image from it. Now let's go ahead and press enter. And you can see that we have built an image. So you can see that right here we had two steps. So the from, so this is the actual line 1 right here. So this is the base image. And then you can see that we have the step 2, which simply added everything in the current directory to this destination inside of our container. And you can see that we have some random numbers here, and I'm going to explain this in a second. And you can see that we built an image and we successfully tagged it as website and then latest. Now, if I go ahead and simply say Docker image and then ls, and now you can see that we have two images, and this is our image. So you can see that the repository is website, the tag is latest, the image ID, so this is the image ID, which is this one right here. And you can see that it was created about a minute ago, and then the size of it is 135 megabytes. So there we go. Now that we have an image, let's go ahead and run a container from it. So let me go ahead and clear the screen and do a Docker PS format. And let me go ahead and simply stop this container. So Docker, or in fact, let me go ahead and remove this container. So Docker RM and then -f and then website. There we go. You can see that we have no containers running. There we go. Everything is empty. And let me actually see if we have any containers which are currently stopped. So Docker PS -a, and then you can see that everything is empty. That's fine. Now let's go ahead and pretty much just do a Docker and then image ls, and let's run a container based off this image right here called website. So let's go ahead and simply say Docker and then run --name. Let's give it a name, website. And then right here, let's simply say -p for the port. So this will be 8080 from the host to port 80 inside of the container. And then let's go ahead and also say that we want to run this in detached mode. So -d or -d. And finally, the image that we want is website and then column latest. And if I go ahead and press enter, you can see that we get this huge ID back. If I do a Docker PS, you can see that we have a container running, and it's running our own image. So the image right here is the website latest. And you can see the name, the ID, and it's mapping port 8080 from the host to 80 inside of the container. And the crucial thing here is that we are not mounting any volume. So this image contains everything that our application needs in order to run. Now let's go ahead and test this in our web browser. And then this was the previous one. So now if I refresh, you can see that this still works. So if I open up Safari and then localhost and then 8080, there we go. You can see that our website is working beautifully. And there you go. You've successfully managed to create a Docker file and then built an image from it and ran a container. If you have any questions, go ahead and drop me a message. Otherwise, let's go ahead and learn a bit more about Docker files. All right, let's go ahead and switch contexts and build an API using Node.js. So we're going to pretty much just switch from this awesome website to building an API using Node.js. So go ahead and install Node.js in your machine. So for Windows and Mac users, the installation process is the exact same thing and very straightforward. So go ahead to nodejs.org and download either the recommended version or the one that contains the latest features. So once you have Node.js installed, we're going to be using this awesome framework called Express. So Express allows us to build APIs and web applications. So once you have Node.js installed, go ahead and navigate to expressjs.com. Go ahead and click on Getting Started and then Installing. So to install is very straightforward. You need to create a folder, npm init, and then entry point. This will be the index.js, and then you simply install the Express framework. So let's go ahead and do that now. So let me go ahead and open up terminal. And what I'm going to do is come out of the website folder. So cd and then ... And in my desktop, I'm going to create a folder. So make and then dir and then API. Or actually, let's name this as user and then service. So this user service will contain every single piece of code that deals with users. So let's go ahead and pretty much just make this lowercase u, and then this also, let's go ahead and say dash and then service, and then enter. Or actually, let's also say API. So user service API, and then enter. Let's go ahead and navigate to user service API. Now let me show you the actual version of Node that I have. So node -- and then version. And for you, it might be a bit different, but this will also work for you, regardless of whatever version you are using. So now let's go ahead and say npm and then init. And go ahead and pretty much just press enter a couple of times. And then simply say yes, it's okay. Now inside we have this package.json. Now let's go ahead and install the Express framework. So npm install -- save and then Express. Just give it a second. And there we go. You can see that was very fast. Now go back to the website. And right here, so on the actual header, click on Getting Started and then Hello World. So right here, you can see that they have an example of how to run a very simple server with one route that simply returns Hello World. So go ahead and copy all of that. And what I'm going to do is open up VS Code. So let me go ahead and simply open. And then in my desktop, user service API, and then open. There we go. Now inside, let's go ahead and create an index.js and then paste that code. So just simply paste everything and save it. Now the way that you start this is if I go back to the terminal, and you can see that we have this index.js. Now go ahead and simply type node and then index.js. And you can see that we have a message saying example app listening on port 3000. Now let's go ahead and open up port 3000 on our web browser. So localhost port 3000, enter, and you can see that we have Hello World. Now let me go ahead and simply change this a bit. So right here, instead of returning Hello World, let's go ahead and simply say res dot and then JSON, and let's return a user. So name, Bob, and then email, bob@gmail.com. So this will be enough. Save this, go back, open up terminal again. So we need to stop this, Control C, and then let me clear the screen and then say node index.js. And there we go. App is listening on port 3000. Let's go ahead and open up Chrome again, refresh, and you can see that now we have a JSON object back. And in fact, this should be so let's go ahead and actually return an array. So an array here, and then close that one there as well. So this is a single object, but we want an array. So let me go ahead and cancel again. There we go. If I open up Chrome, refresh, and now you can see that we have an array of users. And there we go. So you successfully managed to create a very simple API with Express. Next, let's go ahead and Dockerize this API using a Docker file. So currently we have an Express app that simply has one endpoint, and it simply returns a list of users. So let's go ahead and actually take all of this and create a Docker file that will allow us to produce a Docker image. So let's go ahead and create a Docker file. So Docker and then file. So now we have to choose the base image. So let's go ahead and simply say from, and if you have guessed it, so if I open up Docker and then hub, and I can go ahead and search for node, and you can see that we have one verified content, and this is the Docker official image. So this means good news, as we can use node for our base image. So let's go ahead and simply say from and then node, and then let's go ahead and pick the latest tag. So I'm going to discuss tags later on, but for now let's go ahead and use the latest tag. Next, let's go ahead and use work and then dir, so work directory. So what I want to do is actually set the working directory inside of the container. So what I'm going to do is create a folder called app. So basically this means that if you have a folder inside of the container called app, use it, otherwise create a brand new one. And then any commands that follow this line right here will be executed inside of this app folder inside of the container. Next, let's go ahead and pretty much just say add, and we want to add everything. So we want to add everything inside of this directory to the app directory. Next, let's go ahead and use the run command. So run, and right here, the run command allows us to pass few arguments. So the arguments that I want to pass is npm and then install. So basically we want to install all the dependencies from our package.json. So this allows us to do that. And finally, once we have all the dependencies installed, we can simply go ahead and pretty much just type the same command that we did here. So right here, if I cancel this, Control C, node, and then index.js. So let's go ahead and simply say cmd for command, and the command is node and then index.js. And there you go. This is pretty much everything we need for this Docker file. Now go ahead and open up terminal or command line, and let me go ahead and pretty much just press Control C, clear the screen. Let's go ahead and simply say Docker and then build, and make sure that you are inside of the user service API folder. And let's go ahead and simply name this as user-service-API column and then latest. And I forgot to add -- tag or dash T, so dash T for tag, and then where the Docker file is inside of this directory, so dot, and then press enter. And you can see that there are 5 steps. So the first one is from node. You can see that it's pulling node. So these are layers, which I want to discuss later on. But for now, it's just downloading everything that it needs for step 1 out of 5. So just give it a second. And you can see that this is the one that's taking the longest. So this has quite a big size right here, so 215 megabytes. So I think this was me actually dragging this. So just give it a second, and you can see that this ID right here is the same as that one. So just bear with me. Now it's extracting. There we go. So you can see that now it's doing the, oh, actually this is very fast, but basically you can see that it's finished. But let me show you exactly what it's doing. So the step 2 was creating the app directory, and then step 3 out of 5 was adding everything from our local machine to the container, and then step 4 was running npm install to download and install all the dependencies. And then step 5 is the command. So when this container starts, what command shall be executed? Node and then index.js. And you can see that this is the image ID and this was the actual tag. So user service, API, and then latest. And this was actually me copying and pasting, so ignore this. And there we go. Now we have an image for the user service API written with Node and Express.js. Let's go ahead and run a container from the image that we've just built. And what I'm going to do is make sure that the API is not up and running. So let me go to localhost port 3000. You can see that it's not up and running. Now, let me go ahead and check the list of images that I have. Docker, image, and then ls. And you can see that we have 2 extra images. So this one, Node, and the one that we've just built. So user service API. So you can see the tag as well. So the tag is latest and the image ID, created at, and also the size. So now let's go ahead and pretty much run a container from this image right here. So to do that, let's go ahead and simply say docker and then run -- name. Let's name it as user and then -API, and the actual and then -d for detached, dash and then p for mapping the host port to the container port. So let's map the port 3000 and remember correctly. So if I open up Chrome, it was running on port 3000. So this is the port that Express.js listens on by default. So let's go ahead and pretty much just map to that. So the host 3000 will map to container port 3000, and then let's go ahead and pass the actual image. So user -service -API and then column, and then the tag is latest. And I can see that I've got a mistake, so this should be docker and then run, not rum, and then press enter, and there we go. Now go ahead and simply say docker ps with format or without, it doesn't matter. So I'm going to format the ps output, enter. You can see that we have 2 containers. So we have the website, so this is running on port 8080, and this is the API, which is running on port 3000. So let's go ahead and test it out. So let me open up Chrome, and then right here you can see that this was running from our machine before, And now it's been containerized with Docker. So if I refresh, you can see that now it's working. And also our website is listening on port 8080 and should work. So you can see that it's working. And there you go. You've managed to containerize an Express application with Docker. If you have any questions on what we did here, drop me a message. Otherwise, let's move on. In this section, let's go ahead and learn some of the best practices when it comes to writing Docker files. So in this video, I want to cover the .dockerignore file. So far, you've seen that we wrote this Docker file right here that says from node latest. And then we set the working directory right here. And then any command that follows will be executed inside of this folder called /app. So you can see that right here, we simply add all the contents within the host. So all of these files to this folder right here called app inside of the container. And then we simply run npm install. So usually when you write applications, there are certain files that you should ignore. For example, if I was to commit this API to a GitHub repository, I wouldn't necessarily commit this folder right here called node_modules, because this folder right here is created when we run npm install. So in fact, let me go ahead and delete it. So let me go ahead and simply delete. And then you can see that if I try to run this application, so let me go ahead and simply say node and then index.js, you can see that cannot find module express. So what we do is simply say npm and then install or npm I. There we go. You can see that the packages were added and about 50 of them. Now if I go ahead and say node and then index.js, you can see that this time this works. So what we need to do is right here. So because we don't need to include this folder to our build step inside of this Docker file, right? Because this command right here, so run npm install, does it for us. We simply have to exclude this file right here. And so that you understand, by the time you run this command right here, it will include everything in this folder, including node modules. Then you will also run npm install, and that will create the node modules again. So we don't need that. So what we need to do is create a new file, and this file will be called dot and then all lowercase docker and then ignore, and then press enter. Now what we need to ignore is node_modules. And in this file, you should ignore folders or files that your Docker image does not need. So we also don't need the Docker and then file. So we don't need this Docker file, so this one right here, to be added to our image, right? So it adds no value because we don't need this Docker file in order for our application to run. Finally, because I'm going to create a GitHub repository from this example right here, let me go ahead and simply add a dot and then git. So this is the git folder, and I really don't need to include that inside of my image. And for example, if you want to exclude files ending in certain extensions, you simply say, for example, file, or actually you'd say star. So any file ending in, for example, dot and then gulp, for example, .js, something like that. If you want folders, you'd say folder and then / and then any folder under that, right? And this is pretty much it. So I'm going to ignore node modules, Dockerfile, and .git. So now if I go ahead and save this, and let's go ahead and pretty much cancel out of this. Let's go ahead and build the image. So Docker build. And in fact, let me check the image name. So Docker image ls. So the image was user service API. So Docker build -t, paste that. Let's also go ahead and simply say latest, and then dot, enter. And you can see that it's running. It added 50 packages. So this was the npm install, and there we go. And this is how you use the .docker ignore file. If you have any questions, go ahead and drop me a message. Otherwise, let's move on. In this video, let's go ahead and learn about layers and caching when building images from our Docker file. So pretty much every one of these steps, so step 1 to 5, they do create layers. And a layer is used in caching. So how is this important to us? So what I'm going to do is pretty much open up terminal. And right here, let's go ahead and install a few dependencies. npm install -S. Let's go ahead and install React, Webpack, and then let's also go ahead and install gulp and grunt. So basically, I'm just installing random packages that you don't necessarily need. So this is only for demonstration purposes. So go ahead and press enter. And you can see that this will take a while. So it will download React, Webpack, gulp, and grunt. So just bear with me. And there we go. You can see that it added a few packages, and this took a while. So now let's go ahead and open up our code. And what I want to do here is open up index.js. And if I make this smaller so you can see everything. So right here, let's simply go ahead and add another user. So let's call this Alice, and then Alice at, and then hotmail.com. Now let's go ahead and build an image from this. So go ahead and pretty much just press up a couple of times. And what I'm going to do is this one. So I need this command, docker build -t user service API, and then latest, and then dot. So you've learned about this. So now go ahead and press enter. And you can see that these are the steps, and each step, so you can see that right here. So this step is using cache. So you can see that it's using the cache, right? So just give it a second, and you can see that now this will take a lot longer because we are installing a bunch of dependencies, and you can see that it's finished, right? So the point really here is that you can see that step 1 is pulling the node image, so latest, and then work directory is using the cache, but really there is not much going on inside of this work directory. So this is simply saying create this folder if it doesn't exist, otherwise use it. And then we add the source code right here, and then we run npm install. So if I run the application, so let's go ahead and run. So run, just like that. Press enter, and there is a container already. So let me go ahead and say docker rm, and then -f user -api. There we go, that's gone. So if I run this again, and then open up my web browser, and if I refresh, you can see that we have 2 users right here. So we have Bob and Alice. Now let's go ahead and add a 3rd user. So right here, let's go ahead and add Jake, and then add, and then yahoo.com. Save this. Now let's go ahead and build an image again with our changes. So go ahead and pretty much just say docker build, basically the same command. Press enter, and you can see that it's running the same thing. So basically from node right here using the cache, adding our source code right here, and then running npm install. And you can see that took a while. So the thing here is that we can do way better than this. So we can take advantage of caching, because the only thing that we have changed was the source code. So because the source code has changed, right? So let me go back to the Docker file that we built. So because this step has changed, Docker has to recompute every single step that comes after this. So the way to improve this and to make sure that we do not run npm install and download and install dependencies all over again, we can simply take advantage of caching. So let's go ahead and think how we might improve this Docker file. So we know that what we need from this Docker file is two things. We need the package.json and package-log.json. So what I'm going to do is I'm going to set the working directory. And now here I'm going to say add, and then I'm going to say package, and then star.json. So basically, I actually missed the dot right here. So we want to add package.json to the working directory, which is app. So basically now we are adding the package.json, right? And what we're going to do is pretty much run npm install. And then after that's complete, we're going to add the source code. So we're going to add everything from the current directory right here to our working directory inside of the container, which is app. And then we're going to run node and then index.js. So this will improve things dramatically because we don't often change what's inside of the package.json. Surely at the beginning of development, but once the software is mature enough, we don't necessarily add too many dependencies. So we can simply use caching, right? And then Docker will know whether the contents of package.json or package-log.json changed, and then recompute everything all over again. If not, it will just skip this step, use whatever it's been cached, and then pretty much just add the source code and then run node and then index.js. And this will be way much faster. So let's go ahead and give that a go. So let's go ahead and build. So let's go ahead and build this for the first time. So docker build -t user API and then column latest. And it says when using add with more than one source file, the destination must be a directory. So what I need to do is simply say / and then dot. And this should work. And I think I got a mistake. So this should be dot and then / like that. And let's go ahead and give that one more try. So docker build, and there we go. So it's working now. So you can see that right here. So it's pulling the node image, it's using the cache for the working directory, and it's added the package and package.json and then a package-log.json, and then right here it ran an npm install, right? And this is done. So right here, so you can see that step 5 was simply adding the source code, and then step 6, and then step 6 is the actual command. So node index.js. So now let's go ahead and pretty much just add a 4th user. So right here. So let's go ahead and add Maria, and Maria at yahoo and then com.uk, something like that. And then let's go ahead and go back, and now let's watch this closely. So now if I build an image from this Docker file, guess what? So you can see that this was so much faster. And why? It was simply because of this step right here. So right here, you can see that it's using cache, which it wasn't before. And the same for the package and then start.json. So nothing has changed there. And in fact, you can see, so let me start from the top. So right here, using cache. So this is for the working directory. The same for adding package.json. The same for npm install right here. So this is awesome. And then the only thing that changed was the source code, which was inside of this step. And this is much better because now we are using caching, and you can see that building images this way was much faster. So bear in mind when you create your Docker files to think exactly what will change and what will not, and try and make use of caching whenever it is possible. Now let's go ahead and test this by bringing up a container from this new image. So let me go ahead and check the images that I have. So Docker PS, let me clear that. And we have this user API. So let's go ahead and stop it. So Docker rm-f. So we want to stop and remove. And let's go ahead and simply say user API. Now let's go ahead and simply start user-API like that. And this will be using the new image. So press enter. There we go. Now if I open up my web browser and then right here, let's go ahead and refresh. You can see that it's working. We have Maria right here. So Maria was the last user that we added. And there we go. Now we have an understanding of Docker, caching, and layers. Go ahead and drop me a message if you have any questions. Otherwise, join me on the next one. Alright, in this video, let's go ahead and learn how we're going to improve our image sizes with Docker. So let's go ahead and simply check the images that we have. So Docker and then image ls. And right here, you can see that we have a couple of images. So we have our custom image that we've been working with. So user service API latest. And we also have the website image, node, and then nginx. So if you look carefully, so we have this size column right here, and you can see that the size is, to be honest, quite large. So this is almost 1 gigabyte, right? But then if you look into this website, the nginx one, right? This is based off nginx. The size is 135 megabytes. Now, when building images and pulling images, you will see that the time that it takes to download these images is quite large. So one way to reduce the image size is to use the Linux Alpine distribution. So what I want to do is actually show you exactly what it is. So go ahead to alpinelinux.org, and right here you can read about it. But basically, this is an independent, non-commercial, general-purpose Linux distribution designed for power users who appreciate security, simplicity, and efficiency. And right here you can see that the key points are it's small. And you can see that a container requires no more than 8 megabytes, and a minimal installation to disk requires 130. So you can see that, you know, the sizes here are really tiny, really minimal. It's simple and it's secure. So go ahead and read more about the Alpine Linux distribution. But what I want to show you exactly is how we can reduce the file size of our images, because this is very important when you start building a bunch of Docker images. So let's say that you have 100 Docker images, right? So one, you will fill up your Docker registry very quickly, so you run out of space. And we're going to touch about Docker registries later. And the other one is actually, you know, speed. And also in the actual images that we have, sometimes we don't need everything in it. So that's why we use the Alpine image. So let's go ahead and learn exactly how we are going to reduce the file size of our Docker images. All right, so pretty much every single Docker image out there has an Alpine version, or actually an Alpine tag. So right here, you can see that we have a node. So this isn't ours. And we also have Nginx, and they are using the latest tag. So let me go ahead and show you the actual image. So this one is for node. And right here, you can see that they have supported tags. So by default, when we don't use a tag, we pretty much just get the latest tag, or as we've been using tags throughout this video, we have simply been using the latest tag. So right here, you can see that they have a bunch of tags, and the one that we've been using is node. But you can see that, for example, you have 8.16.0 and then Jesse. You've got Buster, but more importantly, the ones that we care, right, because we want to reduce the file size, is the Alpine version. You can see that 8.16.0 and then Alpine, and then you have 8-Alpine. So let's go ahead and pretty much just pull an Alpine image and then investigate the actual size. So let's go ahead and simply say Docker and then pull. And what we're going to do is we're going to pull node and then say column and then LTS for latest and then dash and then Alpine. Now let's go ahead and press enter. And you can see that this is pulling the image from library-node. And you can see that this is 21 megabytes and pretty much it's done. So you can see that it was very, very quick. So let me actually go ahead and pretty much just clear the screen, Docker image ls. And now take a look at this. You can see that now our node image, so latest Alpine, it's only 75 megs. So we went down from almost a gig to 75 megabytes. So this is insane. And you saw that to pull this image was like very, very fast. And remember previously when we pulled this image right here, right? So when we pull this image, this took ages. So, I had to wait because my internet connection was slow. But right here, you saw that pulling this image was very, very fast. Let's go ahead and do the same for Nginx. So go ahead and simply say Docker pull, and let's go ahead and search for the latest Nginx tag. So let me go ahead and pretty much just navigate and search for Nginx. And let's look at the tags that they have. So you can see that they have also Alpine, right? And they have latest. So let's go ahead and pretty much just say that we want the latest, actually Nginx here first. So this is the name, so repository name. So nginx column latest dash Alpine. Press enter. And you can see that it's actually not called Nginx dash Nginx column latest Alpine. So I think that, okay, I got mixed up here. So basically, if we want Alpine, we simply say Alpine, and then it will get the version, right? So basically, these are the versions. And if you don't include the version, right? So if we simply say Alpine, it will get the latest one. So let's go ahead and pretty much just run the same command again. And instead of latest, we simply say Alpine. Enter. And there we go. So now you can see that it's pulling the image. And this was like very fast. So let's go ahead and clear the screen. And then Docker image ls, enter. And now let's look at this. So basically we now have two Nginx images. So this one was the latest, right? And this one is the Alpine version. And you can see that the size, this one is pretty much tiny in comparison with this one. This one is 126 megabytes and this one is only 21 megabytes. And this is awesome. There we go. You now know how to reduce the image file size by using the Alpine Linux distributions when pulling Docker images. Next, let's go ahead and change our own images. So this one, user service API, to use an Alpine version, and the same for our website. Let's go ahead and change our custom images to use the Alpine version, and you will see that the size will become much smaller. So let's go ahead and change for the user service API, and the same for our website. So let's go ahead and open up VS Code or your favorite IDE, and I'm inside of our API, and what I'm going to do here is pretty much change this to Alpine. And I think that right here we use the LTS Alpine. So let's actually double check what's the difference between Alpine and LTS Alpine. So let me actually go ahead and go to Docker, or actually Node. So Node, and right here, so we have the Alpine version and LTS and then dash Alpine. So basically, I think I've used this one previously, but we also have the Alpine right here. So let's actually use the Alpine. So what I'm going to do is pretty much just say Node and then Alpine here, save that. And let's also go ahead and say Docker RM, or actually image RM, and then Node, and then get the actual ID. So let's remove this image. There we go, that's gone. And let's do a Docker pull and then Node column al and then pine. So I think this is much better. There we go, and you can see that this will be super fast. There we go, that's done. So if I do a Docker ls image, or actually image ls, you can see that we have Node Alpine right here, and it's only 79 megabytes. So that's fine. Now let's go ahead and change the actual website. So let's go ahead and open up website. So file and then open and desktop and then website. And right here, this will be Nginx and then Alpine. Save this. Now let's go ahead and build these two images. So Docker build, and we are going to build the user service API, right? So make sure that you are inside of the folder, and then name this as latest, and then simply say dot, press enter. And I always forget the tag, so let's go ahead and simply add a tag, build, and then -t for tag. There we go. So you can see that now it's pulling from Node Alpine, and this is taking a while because of caching. So remember that this layer right here, so this layer right here has changed, right? Therefore, we need to recalculate everything that comes after it, even the work directory. Remember, before it was getting from the cache, the same for package.json and npm install. So we've changed the image, so now it's recalculating everything. So if I actually go ahead and I want to show you this. So if I build the same image again, so this was like super fast because it's using the cache right here. You can see that it's using the cache, using cache, 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 and cache, because nothing has changed. Now let's go ahead and cd back and then go to website, and let's go ahead and pretty much just build website. So Docker build -t and then website column latest. and then dot. Enter. And there we go. You can see that this took like, probably half a second or so. And this is because there isn't much that we have to do in this build, because we simply are pulling Alpine and then adding the source code, and that's it. So now let's go ahead and say Docker and then image and then ls. So now you can see that we have the website right here, right? So the website now is only 30 megabytes and before was 134. So I'm going to explain this later on, but you can see that now we have none and none. So the repository went from none and the tag also went from none. And that's because we are overriding the tag. So it's pretty much reusing the same tag. And because you cannot have images with the same repository and tag, with the same repository name and tag, it simply removes and then uses for the new build. So that's what we did. That's what it did here. So website latest is only 30 megabytes. So you can see that it went from 135 to 30. So this is a big improvement. Now let's look at our user service API. So remember, this was based off Node. So this big one right here, almost a gig. So now it's actually 117 megabytes. And before, you can see that right here. So this one, it was 946 megabyte, which is almost a gig. So there you go. You can see that we've managed to improve the file size of our custom images. If you have any questions on reducing the file size, go ahead and drop me a message. Otherwise, let's move on. In this section, let's go ahead and learn the importance of tags, versioning, and tagging our own images. So basically, tags versioning allows you to control image version, i.e. you have full control of what image you pull and what image your application depends on. And the benefit of that is that you now avoid breaking changes. So let's say that you code against Node 8 today, and then tomorrow Node